In designing the Ed carriage, we wanted to do something that wasn't too obtrusive to our design. We wanted to make it as small as possible and kind of keep it out of the way. And we were able to do that using 4 long yellow connect pieces. We just put the egg in there and it fit perfectly, worked perfectly. Egg survived just fine. Okay, so in terms of our redesign, we had to look at a couple key terms and a couple things that were going to help us redesign our car. We looked at things such as momentum, the lever we use, potential energy, kinetic energy, velocity, mass, and work, and as well as the force. Now, in terms of momentum, we wanted to create as much momentum as possible to get the car going. And if we were able to do this, we know we would get a fairly good score. The lever was probably the trickiest part of redesigning our car because a lever, can take away momentum and can take away basically every component that helps your car move forward. And so we had a hard time designing that, but what we decided to do was just put a little lever on the back, and as soon as we swiped it off the car, the car would release and go towards the ramp. Our potential energy, we try to create as much of that as possible because if you have a lot of potential energy, you're going to have a lot of real energy and a lot of energy that's effectively going to go towards that ramp. And we did that by basically stretching a rubber band from one end of the car to the other and then winding it around a wheel, or not a wheel, but a connect piece, and this created a lot of potential energy. And once it was released, that kinetic energy was then the potential energy was entered into kinetic energy, which was then released, which made the car go towards the ramp and eventually up the ramp. Our velocity, you wanted a lot of velocity, you wanted an increase in velocity, not a decrease. We did manage to do that with our rubber band. The mass, we try to make the car as light as possible. Believe it or not, it's pretty hard because you have to throw in that egg eventually, and we should have taken that into account before we actually designed our car, but we didn't. But the egg didn't add too much mass, as we did go ahead and build a fairly light car. In fact, it's probably one of the lightest cars in the class, and it worked pretty well. Our car was not heavy; it was about 200 grams or something like that, so the car was very light. Work, we tried to make our car do as least amount of work as it possibly could, because if you do more work, just like in human life, you don't want to do more human work. You get more tired as you do human work. It's the same kind of concept. It would be harder for our car to get up that ramp the more work it had to do to get up that ramp. And then finally, force. We tried to get as much force behind the car as possible, but try to make it, the force coming towards the car, as least as possible. And we did this by battling it with a greater amount of force in our favor. So it really wasn't that much of a challenge there, as long as we had good momentum and energy inside the rubber band of the car. Anyways, that's it for our redesign. Our launch went pretty successful. Got second farthest in the class, and went pretty well. We tried to make our mass of our car as light as possible, so we can get so it would be easier for us to attain velocity. It's obviously easier to get something moving faster or accelerating when it is lighter. For instance, our rubber band or trigger system does not have to carry as much weight, and if it's lighter, it does not use much force to create velocity. So we definitely wanted to make our car as light as possible.